In a couple of years, they have built a home, sweet home. Dimension. Dimension. So let's talk about this B, a scripty B. That's a kind of a fancy B. I'm going to write a normal B later, so make sure your B's are distinct. So this scripty B is a basis. This is a basis of R2. If you don't believe me, you should definitely pause the video and explain to yourself why this is a basis of R2. Moving on, I want you to notice that let's say the corresponding matrix. So notice that. The corresponding matrix B so just a normal uppercase B. Okay, putting the vectors in as columns. So I want you to notice that this matrix has a pivot for every row and a pivot for every column. Okay, that is not a coincidence. No, not a coincidence. Okay. The pivot for every column indicates to us that the set B is linearly independent. So let's write that down. So pivot for every column, that is if and only if the set B, scripty B, is linearly independent. And the pivot for every row is also significant. It's the other part of the definition of a basis. That is if and only if span B is equal to R. Well, 2 in this case. Why is that? Well, what it means is that if I have any vector x, y, I can write it as a linear combination of these columns because this matrix here is consistent, always consistent, no matter which x and y I pick. So every vector in R2 is a linear combination of those columns. Okay. So this is true actually in general. So this 2 here can in fact be replaced with an n. So this notion of having a pivot for every row and every column is in general going to give me a basis of Rn. So let's put this another way. So put it another way. So be a subset of Rn is a basis of Rn if and only if, double F, the corresponding matrix capital B has a pivot for every row and column. Okay, the matrix B is not going to make sense if this scripty B is an infinite set, so I should specify that this set is finite, but we'll just leave it as is and accept the fudge for now. So it gives me a nice way to check if something is a basis. You can just throw it into a matrix and see if you have a pivot for every row and every column. But even faster, put another way, put another way. B is a basis of Rn. That's if and only if the determinant of B is, well, this is capital B. I need capital B to have a pivot for every row and every column. So that's going to ensure that the determinant is not 0. Okay, it can't be that sloppy. I should, Okay, obviously B is square. And the determinant of B is non-zero. Okay, so again, determinant of B non-zero is going to ensure that I have a pivot for every row and a pivot for every column. A pivot for every column gives me independence, and a pivot for every row gives me span B equal to Rn.